Okay, in this tutorial, I'm going to build you will have in the last tutorial where you were being asked the differences in this, and this is basically that the river had a great discharge. And in explain to you that these are different discharge, that is the water flowing past point second was as much the fact that it has rained, which it has done in this right-hand photograph, but also to do with the landscape, that there are characteristics the surrounding drainage influence how much water gets to the river and how fast to the river. Okay? And you need to, as we move forward with the topic, and number of these the landscape influence the amount of water to the river. So what we're going to look at today is consider what kind of physical factors. And what I mean by the physical factor is what is it out to the river? Okay? You'll be using this on let's get this going. Think about a drainage basin. You will remember a drainage basin is an area of land which is drained by a river. So I am just circling this area of land here, and water that falls anywhere on into this area is drained by the river that flows down the center of this landscape. Not just the main river, but all its river channels. Okay, so that is the drainage basin. Now, when water lands on that landscape, let's just add some water here. Okay, what's it going to do? Well, it's going to first of all travel down slope because of gravity. And as soon as it comes across a river, it is going to then flow in that river back to the sea. Okay. However, it may not just flow across the surface. It might actually infiltrate into the soil. Now, you remember this idea from an earlier lesson. Infiltration is where it soaks into the soil. And if it soaks into the soil, it will start moving downwards through the soil until eventually it joins the river down there. Okay. Now, it might actually continue all the way down even further and soak into the rock. That's called percolation, when it's absorbed by the rock, and then it will travel even slower through the rock to the river. But it will once again also get to the river. So these are some of the kind of key ideas that you've already established in this topic. Now, let me just think about what can we do to change this. Well, let's just for argument's sake say this area here was heavily forested. Okay. As a matter of fact, let's just say this entire drainage basin was forested. There were trees absolutely everywhere. Now, when water hits the land, it's not going to hit the land straight away. It's going to first of all hit the canopy of trees, it's going to hit the leaves. And therefore, it's going to drip through the trees onto the base of the tree. And then there's a good chance that the tree is going to absorb that water. It could absorb an awful lot of it, if not all of that water is soaked up by the roots of those trees. In this case, none of those 4 water droplets ever make it to the river because they are absorbed by the trees, and then actually, as the trees heat up, they transpirate or evapotranspirate, if you want to use the full word, back up into the atmosphere. Okay? So in this case, if this drainage basin here was completely vegetated with plants and trees, and this one wasn't, any water hitting here is going to get to the river much quicker, and all of it will get to the river eventually, whereas here, that's not going to be the case. Okay. Now, some other things you can see is that the slope here is much steeper in this drainage basin than it is on this one. And because this slope is much steeper, water is going to flow quicker downhill to the river than it will do in this drainage basin. So the actual gradient of the surrounding landscape, the slopes are going to affect. Likewise, let's just imagine that this drainage basin has got very deep soils, kind of 2-3 meter deep soils. That means that an awful lot of water is going to be absorbed by the soil and therefore slowly move to the river, okay, because it's got very deep soils. Let's have a look at this drainage basin. Let's say it's only got very shallow soils, just a few centimeters deep. In this case, the soil is going to absorb very little of the water, and therefore the majority of it's just going to flow across the surface to the river. Okay. Now, what I'm trying to illustrate with you is that there are a range of factors in a landscape, or what we call characteristics of the drainage basin, which can influence whether water, first of all, ever gets to the river. Okay. When a water hits the land, will it ever actually transfer to a river? Will it be intercepted by trees? Second thing we have to think about is how quickly does it get there? Now, why is this important? Because when it does rain on a landscape, what we're interested in doing is seeing how quickly do the rivers rise, okay, and then fall. In a landscape where very little water is absorbed by the landscape, all of the water, in this case, transfers to the river quickly. Those rivers can rise very quick and have a tendency to flood. Let's just say that was this landscape here. Whereas if we look at this landscape, let's just imagine this one's got deep soils, it's got lots of vegetation all over the place, it's got quite flat slopes. In this case, the water's quite slow getting to the river, and therefore the river doesn't rise very quick. Okay. As a matter of fact, it doesn't just not rise very quick, it probably doesn't rise very high because a lot of the water would be getting soaked up by trees and plants. A lot of it would also get soaked up by the deep soils. Okay, so there's a kind of an illustration of how the landscape can influence the river. Now, your task is to think about each of these different factors. Now, I've talked quite a lot of length of vegetation. Okay, so lots of trees are going to intercept huge amounts of water, which is going to slow down water transferring to the river. So very little is going to transfer to the river when it lands on this forest because it's going to get soaked up by the trees. Therefore, the river down here will not rise very fast when it does rain. And if it does rise, it doesn't rise very much. Where if there was a river at the bottom of this slope, well, there's only grass. So yes, the grass will absorb some, but most of it's going to flow across the surface to the river much quicker. So the river will rise quicker and it will also rise higher. I've talked about soil. The deeper the soil, the more the soil can absorb when it rains. And that means if the soil can absorb a lot of water when it rains, then it's going to take a lot longer for that water to make its way to the main river. You've also then got to think about what's in that soil. And if the soil's made up of lots of sand or silt, it can actually absorb quite a lot of water. But if the water's made up of lots of clay particles, then actually the soil won't absorb much. Clay particles are very small and they pack close together, and therefore water can't kind of trickle through them. Whereas sand, as you've ever poured water on a beach, you'll know water can trickle through sand really quick. So if you've got a really sandy soil, it can absorb a lot, whereas a clay soil won't absorb much water. Rock. Now, rock itself can either absorb water or not. So we can see the rock up at the top here could absorb huge amounts of water because it's quite permeable. Permeable is a word to describe the fact that water has got holes in it and can absorb water. Whereas this rock here down at the bottom, it's impermeable. So when water gets to this rock, it will not soak into this rock. Okay, so if the landscape's got lots of impermeable rock, then water is not going to soak into the rock and it'll just flow straight to the river. Whereas if the rock's is very permeable, like this one up here, then it's going to soak up a lot of water and it's going to take a lot longer for water to get to the river. Okay, now we get into a few slightly more complex ideas. The actual amount of rivers in your drainage basin. So this represents the drainage basin here. If a river, like we can see rivers, these two rivers that make up A, these drainage basins have got huge amounts of little river channels, which means that water will never fall that far from a river channel. So wherever I put a little red dot, it's going to be quite close to a blue line. So water's always going to transfer quite quick to rivers when it's got a high drainage density. If a drainage basin's got quite a low drainage density, what that means is there's very relatively few channels. So when water falls on a landscape, you can see these red dots. It's actually got quite a long distance to travel before it gets to a river. Therefore, it will take longer. Therefore, those rivers won't rise so quick. All right, almost done now. I've talked about this one. Steep slopes will mean water will drain very quick to the river. Flat slopes, water will take a long time to drain because gravity is not going to pull it so fast. Although you will notice there are lots of trees in this first photograph. So whilst it is a steep slope, a lot of the water will be absorbed by the vegetation here. Okay. And finally, the actual physical size of the drainage basin has a huge influence. Now, the Amazon is a massive rainforest the size of Western Europe. And water, therefore, that falls here could take months to drain its way down to the mouth of the Amazon. just to do with the sheer size. Whereas if the drainage basin is quite small or quite narrow, where we've got a river here, which is I believe it's the Dee, okay, up near Aberdeen, we can see there. Now, this drainage basin is actually quite small, therefore water even if it falls back here at the back of the river, it's only going to take a day or two to make its way down the river to Aberdeen. And also, it's never that far from the main channel because it's quite a narrow drainage basin. You can see the actual total width of the drainage basin is not that big. It's only kind of about a couple of 100 kilometers. Therefore, water falling here will quite quickly get to the main river channel. So it's not just the size of drainage basin that's important, it's actually the shape. So here you can see quite a wide drainage basin. So this would take much longer for water to drain to the main channel here. Whereas in this narrow drainage basin, a bit like the River Dee on the left-hand side of the screen, water will never take long before it gets to the main channel. Okay. Those were all of the physical factors that can influence the two key things: how much water actually gets to the channel. And when we think about trees, for example, they absorb a lot and therefore less water gets to the channel. That's the first idea. The second idea is how quickly would it take water hitting the landscape to get to the main river channel. And what you want to do to complete this task successfully is read through the pages that are indicated, use my tutorial, and answer the question.